Okay, so for this question, right, we're asked to calculate the AER. So the formula for that is on page 2, so you don't need to memorize it. It's right at the bottom. So I'm going to write it here at the top of the page here. And a couple of things to note from this, right, and it is important you don't miss out on this, okay, otherwise you get the whole thing wrong. I in the AER formula, obviously is the nominal interest rate versus the decimal, okay, so it's important to see that, right, that I is a decimal, okay. So take note of that. N represents how many compounding periods there are, right? And we'll come to that in a minute. But also as well, AER, right, is this sort of formula here. But the answer comes out as a decimal, okay? So it's important to notice then your answer is also decimal. Alright, so let's look at what we've got here. We've got Banai account and Rory account, and we want to see which has got the best potential for investment, what's going to give the best interest. So we start off with Banai, right? We've got a nominal account rate of 3.85%. Okay, so that's the interest, okay, per annum, and we need to write this as a decimal, remember. Okay, so I, okay, following from the information on page 2, will be this as the decimal. So 3.85 divided by 100, okay, because that's what it is, isn't it? Percentage out of 100, and then you get 0.0385. Okay, and then remember that N, right? N is the number of compounding periods. Okay, that's what it says on page 2. So you're not needing to remember this. Now, if it's interest paid monthly, of course there's going to be 12 periods, aren't there? Okay, because it's 12 months in a year. So the interest is compounded 12 times. So then you can calculate your AER. So using our formula, which we've got up there, yeah? 1 plus I, which is 0.0385 over n, which is 12, yeah, because it's 12 compounding periods, to the power n, which is 12, take away 1. So get my calculator on this, right, and I get 1 plus 0.0385 over 12, close bracket, to the power 12, right, so write all that in one go, take away 1, and I get 0.0391, etc, etc. But of course that's a decimal, don't forget, right? That's what is stated on page 2. So times it by 100, and we get it as a percentage, so 3.92%, okay? So that's the actual equivalent rate, right? That's what AER stands for. That's the rate you will get. So even though they say this, you actually get a slightly better interest rate. And the reason why is because the interest is paid monthly. Okay, so the interest is split up over the year, right? This rate here is split up over the year in 12 payments. But of course, the interest compounds itself, doesn't it? You end up earning interest on interest. And if you get 12 monthly payments, 12 interest payments, you're going to be earning a lot of interest on the interest. So that's why it's a little bit more there, okay? So we're going to do the same now with the other account, right? And in this case, we've got 3.86%. So my I in this case, of course, is going to be 0.0386, right? Right as a decimal. Interest paid every 6 months. So that means then the number of compounding periods is 2, isn't it? Because there's 2 lots of 6 months in a year. So AER then will equal, put it into the formula, 1 plus I over the number of compounding periods, which is 2. The power 2, take away 1. Okay? So 1 plus fraction 0.0386 over 2, okay, squared, and then take away 1, and we get out this then as a decimal, of course. So as a percentage, we times by 100, we get 3 point, and I'll go for 2 decimal places, 3.90%. So you could see actually then Banai, you take the greater interest rate, wouldn't you? You get more money that way. So Banai is best for investment, basically.